Here I'm going to go through a way to run a simple one-way ANOVA using the program JMP. I'm using some data on seedling height called SDHT. This is data on the height of little tiny plants, little seedlings of 3 different species grown on the Evergreen State College campus. So you can see I've got the data here in Excel, and I'm just going to highlight that data and get ready to copy it to paste into JMP. I'm going to open up JMP statistics, and I'm going to get a new data table, clicking on New. My data table comes up like this, and it looks a lot like an Excel sheet. I'll go back to my Excel sheet and copy my data before going to JMP, and then selecting Paste with column names. This is a really simple data set. I have one factor with 3 levels predicting one response variable. My factor is species. My response variable is height. I might be interested in how different are these species in their height. So notice the way that the data are lined out with a repeat of my species values. In the species column, you'll see that the species is represented by a 4-letter code, and it's repeated each row for each measurement for a given species. That's an important layout detail for running an ANOVA analysis. When it's time to run my ANOVA analysis, all I need to do is go Analyze, Fit Y by X. I put species as my X factor and height as my response variable. When I press OK, I get a dialog like this, just a scatter plot of the results with the individual data grouped by category, in this case, the 4-letter code for species. To do an ANOVA, I'm going to use the red drop down and pick the first option, Means ANOVA. After I've done this, my one-way ANOVA has been run. You'll see my R squared, my analysis of variance table comes up here, complete with an F ratio computed from the mean squares, which are computed from the sums of squares divided by the degrees of freedom for each source. So make sure you understand the analysis of variance table in addition to the output. I don't recommend copying this particular graph and using this for figures, specifically because JMP likes to use these diamond diagrams for displaying means, which can be a bit confusing. And so it's better to use a bar chart or a box plot for displaying these data. Analysis of variance tells us that one of these means is not like the other, but it relies on several assumptions. One of the assumptions is that we have equal variances. In order to test that each of the categories is equally variable, we can do what's called an unequal variances test, which you can find in the red drop-down menu. It's actually good to do this before you run the ANOVA, but in this case, we're going to run it now. In the unequal variances test, our null hypothesis is that the variances are equal, that each of these categories has a similar spread and variance in the data. So this is one of those rare conditions where what we're hoping in order to run our ANOVA, we're hoping that the null is actually true. And in that case, we would like to fail this test. We'd actually like a high p-value. Or we'd like a p-value that suggests that the variances are equal. You can find, we're going to pay attention to, in particular, the Levene's test here down at the bottom. And the Levene's test has a probability of 0.87, meaning that it is very likely that the null is true and our variances are equal. JMP also immediately runs a Welch's test just in case your variances are unequal, and the Welch's test gets around that assumption. Another thing that we might have done with these data is check that for a normality assumption right at the get-go. Normality is, of course, important variable for running an ANOVA. In order to run a test for normality, what we would have had to do is go to the distribution option under Analyze. I'll do that again so you can see Analyze Distribution. Just like you do in descriptive statistics, you're going to test for normality by looking at the distribution of one factor at a time. It's often useful to also use the by function to do this by variable to make sure your distribution is normal by variable. In this case, I looked at the distribution for the entire data. Under the height option, the variable that I have here, in addition to summary statistics, you'll see that I can get a continuous fit option, and it'll allow me to fit a normal distribution. When I do that, you'll see a normal distribution fit to my data. It's done sideways, and sometimes it's nice to turn this histogram horizontal. To do that, unclick the vertical box under histogram options. After I fit my normal distribution, I can do a goodness of fit test to see if the data are truly normal. You'll find the goodness fit test in the red drop-down under fitted normal. Just like the test of equal variances, the test of normality has the null expectation that the data are normal. And we're looking to see if our data deviate from expectations under the null. In this case, the probability that our data deviate from expectations of the null is 0.75. In other words, there's a 75 or actually 76% probability that these data do come from a null hypothesis. So we're supporting the null. The null hypothesis is the data is from the null distribution. We can support that, and it means everything else we've done in our ANOVA test looks good. And so we can run with the results as they are.